Hey there, students. So I wanted to take a look at a problem from 6.3. And I'm going to illustrate how StatCrunch could be utilized to work the problem and be a helpful tool. But I have found that a lot of times most of the difficulty that students run into when trying to do a problem like this is they just don't really understand what's being discussed. That the vocabulary at this point has become challenging. So I'm going to also use this example as hopefully a guide to remind us and to discuss the ideas of what's being talked about. 6.3 is one section that takes a very big leap forward in the ideas that we've been talking about when it comes to sampling data from a population and the idea of how you look at the sample data compared to the data that you're investigating and that you want to make implications about the entire population. So let's look at, this is number 42 on the homework set, and we can see it's from 6.3. It says, assume a population of 4, 5, and 9. So that means instead of having a population of 1,000 data values or a bunch of people or something like that, our population, so that's the complete data set, is 3 numbers, 4, 5, and 9. And it says, assume the samples of size 2 are randomly selected with replacement from the population. That means out of the population of all 3 numbers, you're going to choose a sample of 2 of them. Then it says listed below are the 9 different samples. So if you're choosing 2 out of the 3, where you could do a little permutation calculation for that, but there are 9 different possible results that you could get. So this is with replacement because you have 3 for the choice of the first number and 3 for the choice of the second number. So 3 times 3 is 9. And so they list all 9 possible samples of size 2 that they're choosing from a population which has 3 numbers. So we're taking 2 numbers out of the 3 to serve as a sample. So then the first thing I want you to do is find the value of the population standard deviation. So again, the population are the numbers 4, 5, and 9. So let's start with that. So how could we use StatCrunch to help us? Well, I'm going to open up StatCrunch just through the question help because we're not using the samples yet. And that's sort of the table that's provided are samples that we could be using, but we don't want to use that yet. And so when I have StatCrunch open, I'm going to put the population in a column. And again, the population is just these 3 numbers, 4, 5, and 9. So now that's our entire population. So we are supposed to get sigma, which is the value of the population's standard deviation. So to do that in StatCrunch, so I don't have to use that nasty little formula, I'm going to go to Stat, Summary Stats for columns. And I'm going to choose the column. And so the thing to remember here is that usually we are finding standard deviation of a sample. And the standard deviation option here is for a sample. And the formula you use for standard deviation from a sample of a population is a little different. It's been adjusted compared to the formula you would use for the standard deviation of an entire population. There's a little bit of adjustment there. Well, because this is the entire population, we don't want to use the standard deviation calculation because that's designed for samples of a population. We instead want to use the unadjusted standard deviation calculation. And that's a little bit lower on the list. If I go down the list, you see unadjusted variance, unadjusted standard deviation. So this is actually the one that you want to use for the sigma, the standard deviation of the entire population of these 3 numbers. You could also use the formula. Now, if I get that, they want us to round that to 3 decimals, so I'm going to grab that and put it in, and I don't have to round up. Okay, so some students will often get that first part wrong because they're using the normal standard deviation calculation instead of the unadjusted one. So then it says, find the standard deviation at each of the 9 samples, then summarize the sampling distribution of the standard deviations in the format of a table representing the probability distribution of the distinct standard deviation values. Use ascending order for the sample standard deviations. All right, so all of a sudden that's where things really go off the rails for many students if it hadn't already. So we want to look at the sample standard deviation for each of these 9 samples. So we're going to get 9 different ones. Then for each one of those, we're going to tally up what proportion or probability out of these 9 of those samples would result in the standard deviation for that sample that we're talking about. So for example, remember the standard deviation is the measure for how far apart the data values are spread. So in this first sample where I got a 4 and then I got a 4, well, if my data set has 2 numbers that are exactly the same, the standard deviation will be 0, because standard deviation is based on how far apart a number is from the mean of the sample. In this case, the mean is 4, the numbers 4 are 0. Again, you probably don't feel comfortable understanding that, but that's the idea. So let's try this. Let's say that I open this data set of all the samples in StatCrunch to see what it looks like. And I'm going to get a new table, so I'm going to get rid of my old one here. So when you list these pairs of values, they don't know how to organize it. So what they do is they list which sample you're talking about, sample 1 through 9. There were 9 samples here. And then x sub 1 means the first value of the sample, and x sub 2 or x2 is the second value of the sample. So the first sample is a 4 and then a 4. So sample 1 is 4, 4. Sample 2 is 4, 5, etc. So, for example, if I'm now going to calculate these 9 different standard deviations, they're going to be based upon the 2 numbers that I sampled. So my suggestion was that if you have 2 numbers that are exactly the same, then the standard deviation you're going to get for that sample is 0. So I'm going to label this 4th column standard deviation, SD, for, well, standard deviation of the sample. And I'm going to suggest that for 4, 4, the standard deviation is 0. And you could calculate that using a calculator, which I'll show you how to do in a second. Similarly, if I look for any place where I sampled and got the same number twice, like 5, 5, that would have a standard deviation of 0 because they're the same number. And then 9, 9 would have a standard deviation of 0 for that sample. Now, what if my sample is like 4, 5? So you could punch that in a little formula because the mean of 4 and a 5 is 4.5, and then you could take the difference and do all that stuff. But let's just say, so you don't even have to think about that formula, I go over to here and I put a 4 and then a 5 in this column. And now I'm going to say that is my sample 4, 5. Well, when I do that sample, I could then tell StatCrunch to calculate the standard deviation of that sample for me. And this is a sample standard deviation, so I would use the normal formula. So I could go to Stat, Calculators, and go to our Summary Stats, and go to Columns. And so now I put that in variable 6 column, and I'm going to just do standard deviation, the normal type, because this is from a sample, and compute. So I get this number, and I'll just say I grab the first 4 decimals there. They're not asking for this number specifically in these. It's going to be one of our choices over here. So when I have a 4 and a 5, I get a standard deviation for that sample of 0.7071. And I'm going to get that same standard deviation anytime I have a sample where I have two numbers that are one value apart from each other. Because the standard deviation is a measurement of the spread of the data. So where else were the numbers one apart from each other? 4, 5 will also 5, 4. So I'm going to take this same value, and when I have 5, 4, I'm going to get the same standard deviation. I could make the column and do that. And so those are only the two places where the numbers are one apart. So now, let's say I go to 4 and 9. Now the numbers are 5 apart. What kind of a standard deviation when I get when the numbers are 5 apart and there's 2 in the sample? So instead of 4, 5, I'm going to change this number to a 9. And I'm going to do the same thing. I'm going to go to Stat, Summary Stats with Columns. Pick column 6. Choose the standard deviation. And I now get this number. And when the numbers are 5 apart and there's 2 of them, that's the standard deviation. That happens with 4, 9. And if I reverse them, 9, 4, they're still 5 apart. And then lastly, I have a couple 5, 9, and 9, 5 that were 4 apart. So that'll make it a little different. So I'm going to change the 4 to a 5 here. Go to Stat, Summary Stats, Columns. Pick number 6, Standard Deviation. And now I get a standard deviation of 2 point stuff. Okay, so what I now have is my 9 different standard deviations. It says, summarize the distribution of standard deviations in the table format by representing the probability distribution of the distinct standard deviation values. So what are the distinct values? It looks like there's 4 of them: a 0, a 0.707, a 2.82, and a 3.53. Those are the distinct values I can get out of the 9 different samples that I took. And it says order them in ascending order. That's from smallest to biggest. So the lowest one is a 0. So I would go over here and say that the lowest one is a 0. So now they want the probability that if you pick one of these 9 samples at random, that you would end up getting one that had that standard deviation. And they want those typed as a fraction. So what is the probability? Well, there's 3 out of the 9 possibilities. 3 out of the 9. Now, it doesn't say to simplify it, so I could just do 3/9, but I can't help myself but simplify that to 1/3. Let me try leaving it 3/9 and see if it works. All right, so what does this mean? This means that I'm saying that if I took a sample randomly from these 9, the probability that I would get a sample that has a standard deviation of 0 is 3 out of 9, because 3 of those samples have a standard deviation of 0. Then the next highest standard deviation is the 0.707 thing. So I would go over here, and that's an option, 0.707. And how many of the samples had that? Only 1 of them. So that would be a probability of 1 out of 9 that I would get that. And then the next highest is 2.83 or 2.828 if I go to another decimal. And how many had those? It looks like this one and this one. So that's 2 out of the 9. So there's a 2 out of 9 probability that I would get that sample standard deviation. And 3, 4, 5, 6. So then the other one should occur in 3 places. Whoops, there we go. And so then my next highest was the 3, 5. Oh, my 0.707 was in 2 places. That's why they're not adding up to 9. This one should also be 2 out of 9. Then the last one will be the remaining 2 out of 9. And that is for the higher value of 3.536. So I can see each of the 9 different standard deviations here. Then I can tally up, listing their distinct values here, and what the likelihood is of getting each of those there. Let's see if it likes the 3/9. Yeah. All right, so right off the bat, that's very challenging for students to understand when they first read this problem. So hopefully this will be helpful. So now what do they want us to do? They want us to find the mean of the sampling distribution of the sample standard deviations. Too many statistics words there. They want the mean of this probability distribution. What would be the expected or average standard deviation when you take all these samples? That means we need to get the mean of this. Well, how did we get the mean of something like this? Well, we go back to last chapter where we had probability distributions with weighted probabilities. So now I want to create these as a probability distribution. So I'm going to go over here and make a probability distribution. It won't take too long. I'm going to list the values in variable 5 column, which are 0, 0.707, 2.828, and 3.536. So there are my values in my probability distribution, and then here are the probabilities. Now, I could try to enter fractions, but I think StatCrunch is usually happy with decimals, so 3/9 or 1/3 is 0.33333, 2/9 is 0.2s, and that's for all the rest. So these are the probabilities that I would get any of those specific numbers. So I now have a probability distribution where my probabilities add up to 1, and these are the possible outcomes, and I can then get the mean or weighted average mean value of this probability distribution. So the way we did that was we went to Stat, Calculators for Custom, and then we select the values are in the variable 5 column, and the weights are in the variable 6 column. And it's going to give us a calculator, but you may recall from our earlier work that on there is the mean value. So this is the mean value of this probability distribution of standard deviations of samples. That's what they're asking for here, rounded to 3 decimals. So I'll grab that, put it in. So why are they doing all this? They're doing all this because they want you to compare sort of the expected or mean value when you're sampling all possible samples from a population and looking at their standard deviations. The mean comes out to be 1.57. But when we took the standard deviation of the population itself, we got 2.160. So that's pretty far off. That's a pretty large error. That's like 40% error or something like that. It's quite large. So the idea is that using the sample standard deviation is not a good predictor of the population's standard deviation, because it's the mean value of all the ways you could get samples is pretty different than the actual value itself of the population. And that means it's a biased or not a good estimator from using this section's language. All right, so how do we make our choices here? Do the sample standard deviations target the value of the population standard deviation? No, because their mean is too far different from the actual standard deviation value of the population. In general, do sample standard deviations make good estimators? No, they don't, because this is not targeted. So we have to say they do not target, sample standard deviations do not target the population mean. Therefore, they are biased estimators. Looks like that's B. And so that's a tough problem. It's challenging in every aspect. They're basically forcing you to do a bunch of work to try to understand what they're talking about in this section. So hopefully this will help. You don't have to use StatCrunch, but it allows you to avoid pulling out any standard deviation formulas as long as you know how to do it correctly. And so keep up the hard work, and hopefully this example will ease the burden of trying to figure this stuff out on your own. Let me know if you need help.